Thank you, Gil. So excited to be here. Actually, excited to moderate such a panel of so many smart people on the panel. Definitely looking forward to a very insightful panel of speakers sharing their thoughts on the cross-section of blockchain and AI. That being said, I would start off to kind of ask, what's your perspective in terms of the current state or revolution of AI? I think a lot of the folks in the audience have heard a lot of the folks from the AI space on what their view is. I'm wondering your perspective, and especially we have GDC next week, GTC. So whoever, maybe Illia start first.
Yeah, I mean, for those who are in the morning, right, I gave some of my perspective, which I think is this is the last technology wave, and everything else will be built on top of it or by it. I think there's a massive question of who's going to control it and how it's going to be controlled going forward. What goes into training data, what goes into decisions, how to use it. And so that's where kind of blockchain space have been thinking about a lot of these questions around governance and kind of representation and equality for a lot, and kind of can contribute. But at the same time, we do need to solve a very specific problems that AI has, such as concentration of data centers, like the kind of monetization for open source, understanding how to solve the sleeper agent problems and models, etc. But I'm really excited. This technology has been kind of advancing very. I mean, obviously, I usually ahead on these things. So I was expecting this to happen in 2018. What we see now, we were effectively pitching that, hey, computers will code and program back in 2017 was our startup. So to me, this is okay, it's playing out. This is actually the thing we were expecting. But I'm looking forward to this actually dramatically advancing how the humanity is interfacing with each other and computing in a positive way. And we just need to make sure that things stay positive.
Maybe I'll just quickly say I'm a little bothered by the fact that this computer runs on 10 watts, and our AI models run on gigawatts. So I think we're doing something wrong, and I'm waiting for the day where we're going to have much lower power AI systems. And the reason why that excites me is because then there's much more opportunities for doing verifiability using a whole bunch of techniques that simply don't apply when they consume so much power.
I thought you were going to say figure out how to make the brain consume gigawatts.
Oh, yeah.
That was, I had a conversation with Boneh. His point was how do we get our brain to supercharge with a GPU cortex?
Could happen.
Yeah, I mean, I think my views are the same, right? AI for the last 2 years is passing the Turing test, and the Turing test has been the consensus kind of agreed upon sign that close to human AI is basically here, and we're not just playing games and doing naive statistical inference anymore. This is the real thing, and so it's at the point where it's something that we really need to take seriously, and then capabilities are just going to keep increasing from here. And I think there is big philosophical questions of who controls it, what role AI will have with respect to our own cognition, what will human AI interaction look like in the future, both at the individual level and at the collective level. So at the level of how organizations and institutions will make use of AIs. And I think a lot of the tools that we're building in cryptography and blockchains are potentially really valuable in terms of expanding the number of possibilities that we have to try to create a stable and good outcome in a lot of those situations. So yeah, and excited to be excited that we can be making so much progress on these things and working together now.
Vitalik, are you excited for the future, or are you afraid for what's coming?
Some of both, Yeah. I mean, I think you got to be crazy for your answer to not be some of both.
Okay.
Cautiously optimistic.
That's your answer. Yeah. Okay.
Cool. Awesome. Thank you for sharing the view. And I think next we'll probably have time to unpack the different verticals, like the trust, the verifiability side, and sovereignty, identity, and some other properties that we think blockchain can actually help. So one thing we can start is more like the trust side of things. I think Vitalik mentioned yesterday's class with Boneh that we can add cryptography to everything to make like more trustworthy. And I think in the future we have a more mature generative AI, a lot of digital content, and people are probably used to kind of entertainment industry consume that kind of content. So wondering where we are in terms of what's the engineering feasible for trustworthy content, and what's still kind of idealistic. We're not really there yet. Whoever feel comfortable, maybe.
I mean, I can start with what we have effectively now running in production. The trusted execution environments, which is a hardware kind of module inside CPUs and now GPUs that enables to run computation where the host machine, at least in theory, is not able to see what's happening inside. And you also have guarantees that exact computation was done on this data and only this computation was done, which is a really nice kind of property that you don't actually get from a lot of other methods. It comes with some assumptions. For example, Intel and NVIDIA not kind of violating the kind of registration process of the hardware. And there is some known kind of side channel attacks, which I think are addressable through a few methods. But it allows to have both confidential and verifiable computation for kind of AI and any other workloads right now. And this has only been possible effectively in past like 6 to 8 months since the kind of new Intel TDX and NVIDIA Hopper supporting that and having effectively a trusted bridge between these two devices. And then Blackwell actually expands that and supports, going to be supporting a whole cluster of Blackwells, whole cluster of machines now inside a single trusted zone. So you effectively can even train models in a fully kind of in a fully trusted execution environment where you know exactly the data and code went in, and the kind of model output is indeed production of this code, which is something we really don't have right now at all. And we actually kind of, the open source right now is actually not open source, right? It's open parameter models, and we don't know what source went in, right? So we actually have no idea like what these models are basing their decisions on. So we actually are moving into a world where we actually can ensure that and have even open source models which are sponsored by, for example, Crypto Token, to build models community owned where we know exactly all the components of this.
Yeah, I'd actually love to discuss TEs more. Sure. Maybe I'll switch topics just briefly. So we've been working, and I'm kind of excited about the fact that all of our content is going to have some provenance information attached to it. I guess the standard for this is called C2PA, content, provenance, and authenticity. With basically, my guess is that moving fast forward 5-10 years, content that does not have provenance information attached to it is just going to be dropped on the floor. So you try to upload something to a social network. If it doesn't have provenance, they're going to ignore it. Yeah, and so that actually has huge ramifications to our society. I guess what's been interesting to me is what do you do if you want to do post-processing edits on authenticated media? How do you do that? And it turns out there's like really cool, well, I'm a cryptographer, so everything, I'm always looking for a nail for my hammer. And so really cool zero knowledge techniques that allow you to do post-processing on media that has provenance attestation. But there are lots of really beautiful questions around privacy and security of those systems. Happy to get into those if there's interest.
Yeah, we have a section for privacy.
Oh, okay.
Dive
Great.
into it. Yeah. If you have anything you want to share, otherwise we can go to other.
Yeah, I mean, what was the question?
So the question is, we have like increasingly artificial generated content, and trust is being like very important, or increasingly more important, and we think blockchain could play a role there.
What do we do about deepfakes?
Yeah, indeed. I mean, I think, I actually think deepfakes are a little bit overrated, and the thing that's underrated is shallow fakes, right? And the way that I think about this is, on the one side, if you just like I think if you ask the question, like say, to what extent are there known instances of deepfakes making a significant impact on electoral politics, compared to what we would have expected at this level of capability, like I personally actually think the answer is surprisingly low, right? And I think part of the reason is like we actually have some level of provenance mechanisms that we just don't really think about, right? Basically, if someone says something, then like people ask for confirmation. There's an official account you can give or not give confirmation, and then it's like if a person is the type to not easily be fooled by a fake, then like they would wait for those things. But then on the other side, you have the problem that like I've even seen lots of examples of just screenshots like tricking people, right? Like even one example, like I think for myself, like literally a week ago is someone just like randomly like put out a screenshot of a spreadsheet of these are the people attending like Donald Trump's crypto dinner, and it's like according to that spreadsheet, like I was invited and I'm going, and like I discovered from the internet that I am supposedly going to Donald Trump's crypto dinner about like 48 hours away when I already had other totally incompatible plans in Europe. And it's like, wait, how did this happen? And then meanwhile, I go check on social media, and it feels like a lot of people already like seem to have just updated their opinions of me based on this like completely fake information, right? And you see like screenshots of tweets, like screenshots of all kinds of things, right? And so like I'm a bit skeptical basically of the extent to which AI itself like actually makes that bump. I think it's I think there are individual places where actually even very underrated locations where it is a big deal. So I think the places where it is a big deal is like individual social engineering attacks, right? So like there have been instances of companies losing $25 million because someone pretended to be a person using AI and like asked them, hey, quickly send a transaction over here. And there's a lot that we really haven't done to harden ourselves against that sort of thing. But like I generally see this as like a much broader problem of needing to upgrade all of our public epistemic infrastructure so that like it's so that we can know like where things came from and like what things are true and what things are false in general. I mean, even like if you take the concept of screenshots, right? Like that itself is something where theoretically you can totally make something like that's an easily solvable problem. Like if you don't even need fancy cryptography. You just need to like probably like layer a Merkle tree onto the HTML DOM in the right way, and then like you should be able to like click on an HTML field, and then you get an attestation that says like, hey, Twitter actually created this thing, right? So I guess my conclusion from all this, right, is that we should not like underestimate the really dumb stuff, both from the perspective of like attacks and threats and from the perspective of solutions, right? Like there's both like the problem of advancing the frontier, and then there's the problem of just like basically picking up behind everyone else's work and like making sure all of this stuff like actually gets incorporated into the infrastructure.
Yeah, I think Vitalik actually brought up an interesting point where like want to use blockchain to like being like traceable, the traceability feature of it, and transparent feature of it to bring it to AI system. But in the future, we probably will increasingly rely on AI system for decision making, especially critical decision making. That being said, I bring another interesting question about accountability, especially critical decision making of AI systems. Do you think, what's your thought there? Do you think like blockchain will play a role, or the overall accountability way how we make a certain decision accountable will change either as a personal level and also the potentially jurisdiction or legal aspect? What's your thoughts? Anyone want to take it first?
Well, I guess what do you mean by accountability?
Like, for instance, they made a wrong decision, right? The AI system, everyone just rely on efficient, or they thought it's efficient, and made a wrong decision. And then there's some consequences.
Right.
Who is reliable or responsible for the consequences?
Right. Yeah, I mean, I think there's like, so this is like the standard, Yeah, even like one economics question, right? Of like basically fault assignments, right? And generally, yeah, like you want to assign fault to something, to like some kind of entity that like one like actually can do something to increase risk or decrease risk. So you don't want to like put liability on the weather because like the weather just is what it's going to be. You want it to be something that actually has the resources so that it can pay up, right? So if you have some system where like the last mile decision gets made by like just some totally random person and it ends up causing like $1 billion of damage, like you're not going to be able to go after the random person in principle, right? And so if you want the appropriate level of caution to be put into that decision in general, like you have to like put the focus on something that's a little further upstream of whoever that individual is. And I think it's a lot of that depends on context, right? So one part of and there's a difference between like a use of AI in different kinds of institutions and different kinds of contexts, right? So there's obviously the question. Well, like one type of problem is like what if some like individual or some institution just like does something completely illegal, right? And then another type of question is like within the context of some particular organization, then like if an AI gets used as part of decision making, then there's someone who made the decision to use that AI as opposed to using a different AI. There's someone who made the decision to build the AI in that particular way instead of building it in some other way. And I don't like the answers to me are always going to be case specific in a whole bunch of ways, but I think the general principle is that you want to like concentrate responsibility on actors who are relatively well resourced. You want to avoid like creating a kind of unlimited liability type of situation. You want to avoid creating something that ends up like accidentally concentrating power, basically by like forcing everyone to get some kind of intermediary to absorb the risk. That's like these are principles that a lot of which we've seen in the pre-AI world, right, and which I think still make sense.
Yeah.
I think, maybe worth adding is the benefit is we also have now tools, more tool set, right, with AI to actually do things that normally would be expensive and slow to do, right? So for example, as AI is making decisions, you can have an AI lawyer to effectively review, that all the cases are, covered in the whatever kind of system or contract or decision it's making, right? You can have, AI court, which is way faster, right? Like normally court is extremely slow process, extremely expensive because it, takes people and takes kind of a whole process to do. But you can have now kind of AI court systems which are effectively can be injected directly even in the conversation between two different agents, them reviewing the conversation, understanding the intent and the commitments, and seeing if they are indeed satisfied in the process of this interaction. So we have now interesting tools to kind of add to our toolbox where we can kind of have fast-moving, effectively decision-making that now can be also, arbitrating things or deciding and kind of ruling things out, and then you still can back it up by humans when, if people or agents are not satisfied with the outcome. And then the other piece is actually math. I think one of the fundamental things that we will need to is to upgrade all of our kind of infrastructure systems, starting from like, kind of networking code on the networking cards, because they're all written by humans. Now they're written by humans with AI help, and that means there's more and more vulnerabilities being introduced to this code. And so the only way to stop this problem from proliferating, because the new AI models are trained on the output of now themselves, is to make sure that all the code itself is formally verified. And so you actually have mathematical properties from the code, right, that when you're sending somebody money, they're actually going to return you money back, at least as much as you sent, right? I mean, that's a basic smart contract requirement usually you have. And so you can actually apply these properties to services as well. And so you can require that other service, be that AI agent, AI decision making augmented, or a company, that they prove to you that whatever they do, right, is actually will satisfy the properties you want. And so I think between kind of AI jurisprudency system and kind of form verification where you can actually get the a next level of kind of quality and properties from the system for things like where decisions are going wrong. Like you can either stop or balance out a lot of it.
So that's a really interesting point. You're saying the prevalence of AI code generators is increasing the need for formal verification.
Correct.
It's a very interesting point. I want to go back to your point about the courts, AI courts. We have some lawyers in the audience. I think they just literally had a heart attack when they heard you. When they heard you say that. One, maybe to add my 2 cents to that is, I think we had a couple of earlier talks today about adversarial examples against machine learning.
Yeah.
So normally when you see the model, you can always come up with an example that the answer, the answer is, what the answer should be, but the model is 100% confident in the wrong answer. So if you have an AI court, I just wonder if you can kind of manipulate the evidence just a little bit so that it's clear that the person is guilty, but the AI model says, no, 100% this person is innocent.
So I mean, it's the same true about humans, right? If you know the humans, you can manipulate and
not to the same extent though. These AI, the adversarial examples,
it's easier and
much worse on AI than they are on humans.
So see my previous point about TEs and making sure all the models are actually not visible even to the humans, and you have rate limiting and you have like restrictions on how you can use them. And I mean, to be clear, like there's still more research on how to prevent this, but you can also have an expert panel of different models that now each one of them. I mean, the same thing we're doing. We have a jury, 12 jury to make sure that no single person can be coerced into a specific decision. So I think we can build a system for that.
Yeah. So actually, my view on this issue is that I generally don't like the idea of like enshrining a single model and putting a single model into a position of power. And the reason why is, of course, 1, the adversarial example issue. 2 is the fact that AI is rapidly increasing, and like you have to change the model every 3 months. And so if your theoretical mechanism is like this model is in power, your actual mechanism is whoever has the right to upgrade the model is in power. And so the thing that I favor instead is like setting up mechanisms where these mechanisms have like often even human input that's like somehow providing an alignment signal, and then you basically have an open market where people can provide AIs so that can participate in decision making, and the rules of the mechanism are set up in such a way that if the AIs provide decisions that are, on average, in the same direction as like where some sophisticated human jury wants, then those participants make money, their share of the participation in the system increases over time, and if not, then their participation decreases. So one example of this is something I call distilled human judgment. Basically, imagine, so if you take one simple case, like imagine you have an internet forum, and let's say within that internet forum you have a community, and within that community you have some specific set of rules for which posts are considered acceptable and which posts are not considered acceptable, right? And then imagine that if within that community you have some mechanism for, let's say, random sortition choosing a human jury, and then that human jury is the ones that's like treated as the ultimate source of alignment or the ultimate source of information of like what the values are. Obviously that jury is not going to be able to do like actually make good decisions on 1 million posts. Like you don't want to burn a juror with more than 5 questions. Once you get past 5 questions, a person's eyes glaze over, right? And so what you do is anytime there's a post, you create a micro prediction market, and you just let anyone with realistically with an AI participate, and you just have a prediction market on the question: if this post went to the human jury, then basically would the human jury say that this post accepts the rules or accepts the post, or does it not accept the post? And then you just take a random sample of them, and you only have, like, the jury only ends up checking a small random sample, right? And then for the rest of the post, you're basically relying on the AIs, right? And the nice thing about this is, like, you're basically hiring intelligence from the open market, and as an institution designer, like, you don't have to deal with the thorny problem of where the AI is coming from. Do you agree with their biases? Do you not? Or do you not agree with their biases? Because instead, you've set up a system where it's in their interest to, like, basically do the best possible job of copying the biases of what the original human jury is, right? And so you're not kind of like adding this totally like random extra source of power. Like, you're basically sampling from the open world, and you're taking you're basically asking people to, like, provide sources of, like, cheap intelligence that are as aligned as possible with this, essentially whatever guaranteed or very likely to be safe and aligned, but higher cost signal that you provide, right? So, like, I think you can do this kind of approach for many things, right? And I think you generally, like, in general, for these mechanisms, right? Like you don't want to just think about replacing things that are done today. You want to think about opening new frontiers, right? And in this case, like, thinking like micro decisions and in places where there are millions of micro decisions are a really interesting place to explore these kinds of mechanisms, and like, then we'll also, like, be able to, like, actually see in real time, like, how effective like just any AI powered decision making is.
Awesome. Yeah, as the panelists said, there will be, like, some unforeseeable changes and potentially some consequences and damages that once we let the AI out and make a lot of decisions. And I think Vitalik made a very interesting point about more, like, decentralized AI and also more like the defensive side of things. I think it was very much aligned with DIAC. So I think we have a bit kind of different crowd than yesterday. So do you want to let the people here know, explain a little bit more about DIAC, especially tomorrow we have the DIAC day?
Yeah, so DIAC is decentralized defensive acceleration, and so it's the way that I think about it is basically that if you have the type of like philosophical mindset that would lead you to be interested in things like cryptography and blockchains, then what kinds of conclusions about where to go in technology in general does that imply? And the general idea is basically to look at new areas of technology and look at specific directions to push technology that can expand human capability, but then at the same time also mitigate any risks that come, but in particular mitigate those risks in a way that avoids needing to have this like global centralized agreement on one authority that says on behalf of everyone what is good and bad and what is true and false, right? And I mean, cryptography to me is an excellent example of this, right? Because if you think about what cryptography does, it basically does a pretty good job of enforcing the policy that, say, if I send a message to Dan, then I can read the message, Dan can read the message, other people can't read the message, and it enforces this policy without needing to have some centralized actor be able to say, actually make a decision on behalf of everyone of who should be reading this message and who should not be, right? So you're trying to reduce risk, but reduce the risk in such a way that pushes all of the power and authority in a way that is as local and as individual or community level as possible. And there's analogs of this in cryptography. I think there's analogs of this in info and epistemics and how do we make better forms of social media. Analogs of this even in biotech and dealing with diseases. And a lot of, and this covers a very wide range of technology, right? It covers things like cryptography and formal verification. It covers secure hardware. It covers epistemic technologies, so technologies for collective truth finding that like don't try to pre-assume one particular tribe that is in power and that knows better than everyone else what the truth is, and like even similar things in bio as well. So yeah, I think it's very exciting space.
Awesome. Yeah, you can learn more. Tomorrow we have more content related to DAC. Yeah.
Actually, it is interesting to discuss it just a little bit more.
Sure,
So you're saying this could be applied in biology, and can you give an example from biology? Like how would this work?
Yeah, and so I think one simple question is like, how do we stop pandemics, right? And I think,
goal.
yes, like what we saw with COVID, I think, is like in a lot of ways, definitely some successes, but also a lot of failures, and a lot of them even had to do with centralized authority, right? In the sense that there was, like one group that a few small groups that were controlling the information of like where are the viruses coming from? Are these viruses dangerous? What happened? Should people be worried? Like what should people do? And this ended up intersecting with politics, and of course, ended up creating large groups of people that ended up being, like I would say, arguably like needlessly like opposed or fighting each other when really we could have been collaborating together against the virus, right? And so the question is, can we create open source tools that can give all of us better information about like where the diseases are coming from, what kind of diseases are they, should we be worried? If there is a vaccine, then can you make the vaccine open source and design it in such a way that the safety information is as publicly auditable as possible. So that's also work that's being done. In terms of protecting against the disease and preventing spread, so things like air filtering, right? So just very passive technologies that don't get in the way of any person's regular life that could actually be deployed in rooms like this one pretty easily. So there's actually a whole array of technologies that can interrupt a pandemic at like every stage of the pipeline, starting from early detection, going to preventing transmission, going to treatment. And these are things that can be developed in a fully open source way at a surprisingly low cost. And I mean, even there's a lot of places where there's interesting intersections with cryptography, right? Because if we look, like one of the important things is just like data and testing, right? Like if you have a hotspot, like people needs to know like where are they in locations where they need to be particularly worried, or are we in locations where there's particular value right now in having some kind of organized public health response? But then at the same time, the challenge is, well, if you have all of this data being collected, like there's a lot of like pretty scary and dystopian stuff that can be done with that data, right? You can extract a lot of information about people's private lives, even from things like air sensors. And so the question is, well, can we design this stuff in a secure hardware way? Can we design this stuff in a way where the data is being analyzed in a cryptographic way, so you can extract the pieces of data that you do care about without actually like leaking the data that's unnecessary and potentially risky. I mean, there's even like ways to combine like things like differential privacy, things like various forms of homomorphic encryption and multi-party computation. Like there's pretty interesting actual applications for all of these kinds of tools, and what you get out of it is a civilization that can basically have like even more pandemic resistance than what China had in 2021, but at the same time, like do it in a way that's respectful of everyone in society and all of their different preferences, and leave people's ability to continue going about their daily lives in a position that's like even more normal than like say it was in Sweden, right? So
Definitely a great goal to shoot for.
Exactly.
Sounds like there's a dip in for prevention of viruses there.
Yeah, lots of prevention.
Awesome. So we'll not have Peng anymore.
Well, not yet. We haven't built that.
Well, once we have it.
Yeah.
So Awesome. I think Vitalik also mentioned briefly on the privacy side. I think it's interesting. We still have a bit of time to dive into that part of things because we're increasingly more digitized, so privacy become more and more important. And also, right now, it seems like agent technology is fast evolving. I think in the future, you just fully rely on agent and just represent you a lot of your data, especially self-owned AI. What's your thought around the agentic or like future where we just rely on AI and how to better protect the data privacy for users in general?
Yeah, I mean, I can start to continue my spiel, but
It's all tease.
yeah. Well, I think the important part is right now the individual users sadly don't care about their data confidentiality and privacy, and that's a fundamental problem we kind of need to deal with, right? Now, the way to deal with on one side is to tell them that they should care about, but obviously that on itself doesn't work. Now, the interesting thing is, I think the developers, the agent developers, the model developers do care about this because they are actually compliant, like they need to comply to all of the regulations that are coming. It's also dealing with users' data is extremely toxic, right? Like your single employee can, like on purpose or accidentally leak a ton of user data. Like you need to build a lot of protections. You need to build a lot of systems to do that, right? If you're a company or corporation, you cannot use, right now, for example, you cannot use OpenAI for a bunch of stuff because you can accidentally leak your users' data, right? And that is a massive liability for your own company. And so there's a lot of like actual use cases why, as a developer, you actually want to care and use these technologies we're talking about because this removes all of these issues and liabilities from you and really enables you to build just the use cases you want without kind of additionally, like it takes, easily can take like tens of millions of dollars to build a proper kind of like infrastructure to deal with private user data in such a way that like neither your employees nor like accidental data breaches can penetrate it, or you can for free get it from trust execution environments and kind of the blockchain tech that we've been building for past multiple years. So I think like to me that's actually the interesting shift where traditionally we're like, hey, you should care about privacy. Now it's like, hey, the developers who are building this tech care about privacy because they need to. This is like to go to market. And so now we actually just offering this tech to them, and they naturally offer this now to the users. And the users actually getting an interesting benefit because, again, if you're using OpenAI, if you're using all these tools, they are afraid of touching all your sensitive data, right? They'll be afraid of getting a medical history. They'll be afraid of getting your financial information, right? If they leak that, they're like, the company is, in massive lawsuits. But if, the stack is running on, provably confidential computing, you're now able to upload all this data and have your AI actually being able to reason over it and give you medical suggestions and, find better medicine and maybe, build a vaccine of it. So we're actually getting like a benefit of better products as well. And that's, I think, where the kind of, where we actually get adoption is really better products because they can have access to more data running on provably confidential computing that now developers want to deliver because this is simpler and easier and faster for them to go to market.
Do we have to stop?
It's fine. You have it. Yeah, sure.
Actually, Vitalik, why don't you go first then?
Sorry, what was it?
About privacy.
The
What's your view of privacy?
user data.
Yeah, user data. I mean, like, I'm not gonna like friggin' upload my entire like hard drive and chat history to like your stupid SaaS application. I'm sorry. So, like either bring the model onto my computer or figure out a cryptographic thing and like make, and then also like build the infrastructure around it so that I can know whether or not to actually trust it, right? And I think, for every, as you said, like for every paranoid person like me, there's also going to be even more paranoid institutions, right? And and institutions are like basically making decisions like this on behalf of a very huge number of people. So I think figuring out how to get the benefits of AI operating over over private data without actually the risks of like sending our private data around everywhere. And like actually, once we get into BCI 5 or 10 years ago, or in the future, like that's literally gonna like involve our thoughts. Like, no, I'm sorry, but like Mark Zuckerberg, you're not reading my mind, right? So yeah, like.
But the ads are going to be so targeted.
Amazing. Well, then I have to, we all have to trick the computers into thinking we don't have any money, and that's and that's why we also need privacy-preserving digital cash that can be done with zero-knowledge proofs on the blockchain.
Yeah, actually, if I could just add to that really quickly. I mean, I differentiate between different types of privacy, right? There's privacy of communication, there's privacy of storage, there's privacy of finances, and there's privacy of ownership, right? There's lots of different types of privacy. I'd say privacy of communication is kind of necessary to run a democracy. I don't know how you run a democracy if the guy in power can read the opposition's communications.
UK solved it. They just said, do not use cryptography.
Do not use cryptography. Great. Good for them. Yeah. Yes. Oh, you mean with Apple? Yeah. That's right. So that's privacy of communications. When it comes to privacy of finances, there are all sorts of levels. And there, I guess it's kind of late in the day, so we can kind of be a little controversial. In that there are some people think like complete privacy of finances is the right thing to do. You should be able to transfer $50 million from point A to point B, and nobody will ever know that it happened. There are other people in the world who think maybe that's not such a great thing to do. And then there's a point in the middle, which I would call compliance privacy. And in fact, with privacy pools and Railgun and so on, they're actually definitely are providing privacy with compliance. I kind of like this area because in some sense it makes the privacy problem more interesting. Complete privacy, we know how to do. Yeah, there's sort of all sorts of cryptographic techniques that give you complete privacy. When it comes to privacy with compliance, that's kind of a new question that raises lots of interesting technical challenges. So there's actually lots to work on. So I kind of enjoy the fact.
Enjoy the challenge?
Enjoy the challenge, the technical challenge, yeah.
Yeah, there's a lot of things, I think, on the privacy sector that Dan Boneh is working on. That
I think the challenge with compliance is like who decides what's compliant.
Absolutely,
right?
yes. That's right. That's unfortunately, that's right. That's not my job.
Which government?
Oh yeah.
Right. There's now multiple pillars that are being formed, right? Effective to decide what's compliant for them.
Yeah.
So,
and different country and different block might have different decisions.
When we're building global currency and global payment system, right, it becomes a pretty interesting challenge of like which compliance are you even supposed to comply to?
Yeah.
And like how do you overlap compliances between different systems?
Yeah, I totally agree. It's a super interesting problem. I don't think that we've solved it just yet. It might be one of these things that we never solve it, right? We kind of maybe design for one set of requirements, and then we realize, oh my God, this is not what we want. Then we have to design for a different set of requirements, and sort of it's a problem it's a problem that always evolves.
Yeah.
I
think
interesting.
It's probably going to evolve, and also the regulators are really lagging because they really don't understand tech. They're probably still trying to figure out how Facebook works. So they are lagging, and usually they want to see things happen first and then come up with rules and regulations. That's why, but I think you brought a very good point. There's a lot of disruption and changes, and I think it'll be very interesting to see, and things will evolve. Cool, awesome. So we have awesome discussion and had a good time for the past 40 minutes or so. Thank you so much, Vitalik, Dan Boneh, and Illia for your time. So that's like the end of the panel. So we'll go to the next speaker. Thank you guys for your time.
Yeah. Thank you.